Okay, I apologize that I'm not there, but we are going to go over the exact same thing I would have gone over in class. Make sure you are listening with headphones. And make sure you copy it down in your notes or wherever it is you do in-class stuff normally. So the essential skill is graphing trig. So all these graphing days, that is what your new essential skill is. One thing we are going to ask every single time is it odd, even, or neither? We talked about this in chapter 1 when we did transformations. So copy this down, pause the video, because I'm going to keep talking. That's the best part about videos, is you can pause it to copy this down. Odd is when there's rotational symmetry. So we did it algebraically a lot with this part, the plug in the negative x and see if you get the opposite of the equation. But we're going to try to do it visually because we are going to graph them. So if you already have it graphed, visually is the best way to do it. So if you rotate your paper 180 degrees, which basically means upside down, and it's identical, the graph is identical to the original, that's an odd function. If you can fold your paper on the y-axis and the graph lands on itself, that's an even function. So again, pause it and write these down if you haven't yet. These were better on graph paper. 1, 2, 3 kind of lined up nicely for me. 4, 5, 6 didn't line up as nicely for me, but assume that these are symmetric graphs. Notice it's a lot of sine and cosine graphs. And then we also have 2 that look like a cubic, but those are going to be tangent graphs. You'll learn about those later. So for number 1, do you think that's odd, even, or neither? So mine's a video. Obviously, I can't flip it upside down. But if you copy that and then you flip your paper upside down, it should look exactly the same. Number 1 is odd. Number 2, odd, even, or neither. If you fold your paper on the y-axis, every point should land on a matching point. This is even. Number 3, odd, even, or neither. Fold your paper on the y-axis, every point lands on a point. This is even. Number 4, odd, even, or neither. Notice number 4 looks just like number 2 and 3. It's just been moved on the graph. But because it's been moved, if I fold it on the y-axis, it's not going to land on itself. And if you flip your paper over, it's going to be like down here, right? So it clearly can't be the same. So this is neither. So it's not that every cosine graph is even. In fact, let's talk about how we know if something's even. What was different between 2 and 3 and number 4? Things are even if you have a relative min or max as the y-intercept. Must be y-intercept. So the top of a hill was the y-intercept here. Top of a hill was a y-intercept here. It also could have been the bottom of a valley, but my hill was not on the y-axis for number 4, so it was not even. 5, odd, even, or neither. Again, you have paper. If you sketch it and then you rotate your paper upside down, it should look exactly the same. This is odd. Number 6 is almost the exact same graph, but it's been shifted down. Because it's been shifted down, if you flip your paper over, your graph's going to be up here, which is not exactly the same. So this one is neither. So those were almost the same graphs, but one of them was odd and the other was neither. So when can things be odd? Or things cannot be odd. I want to write down odd. Cannot have a vertical shift. As soon as you shift something up or down, when you flip it upside down, your graph is going to go the opposite way. So an odd graph cannot have a vertical shift, which, remember, that's your D value, which I like to make green, right? It's the same as first semester. As soon as they add or subtract a D value at the end of your equation, it cannot be odd. Okay, so sine and cosine. Pause the video, write this down. We're going to put it in graphing form first. I'm just going to go right here. Y equals 1/2 is fine, sine. Just like transformations from first semester, this needs to start with a single positive x. So clearly I'm going to factor 1/2 out. But remember, you're dividing by a fraction. When you divide by a fraction, you flip and multiply. Or you think half of what gives me negative pi. So that must be negative 2 pi. Also because pi divided by a half, negative pi I guess, is negative pi times 2. So we've got to be good at our fractions again this chapter. Okay, once it's in graphing form, I'm going to color code this like I did in the video you watched last night. A was yellow, B was pink, in the parentheses, C was orange, and D is green. The answer blanks you see on your screen right now are supposed to be the ones you can answer before you graph it. So now that we've done that, I'm going to color code my answer blanks as well. Go ahead and start answering these answer blanks. So amplitude is a height. Amplitude is a height. It is always positive. Some of you are going to get it wrong on test day. Luckily, this one is already positive a half, so the answer stays a half. But if it was negative a half, my answer would still be a half. The height of a hill is a positive number. Since there's no negative sign, there is no vertical reflection. Period for sine is 2 pi divided by that pink 1/2. 2 pi divided by b. Just like before, when you divide by a fraction, you flip and multiply, so the period of this is 4 pi. Phase shift comes out of the parentheses. It says minus 2 pi, but that actually goes right to pi. And vertical shift does what it says down to. So we need to make a table. So this is clearly a sine graph. Sine theta. Okay, I like that better, sorry. So this is a sine graph. Remember I told you the unit circle is going to be important. So as you start thinking about your sine curve, there's my tiny unit circle. We always start here because that's 0 on the unit circle. 0 radians, that's x. Is sine x or y? Sine is the y value. And at that point, it has a 0 y value. Then you're going to go counterclockwise like we always do, and we're going to hit all the nice intercept points. So up at the top, that's pi over 2. The y value there, because I'm doing sine, is positive 1. Down around to there is pi radians. The y value there is 0. Down to the bottom is 3 pi over 2 radians. The y value down there is negative 1. Once you get back to where you started, you've done a whole circle, that's 2 pi, and the y value there is 0 again. You need to be able to come up with these points. Then x over b, so I would write down x divided by 1/2, but that's not what we do. Instead of dividing by a half, that's the same thing as multiplying by 2, 2x. Opposite of minus 2 pi gives me plus 2 pi. And then 1/2 y minus 2. Take a second and pause the video and see if you can fill these in. I'm not always going to show all my work, especially when they're easier like this. 2 times 0 plus 2 pi. 2 times pi over 2 is just pi plus 2 pi. 2 times pi is 2 pi plus 2 pi. Once I get this far, I can see the gap is clearly plus 1 pi every time. Plus 1 pi every time. So if you're satisfied with your first 3 answers, you can use that pattern. Plus 1 pi, plus 1 pi. They're always going to have a consistent distance between them. It's not always going to be plus 1 pi, but it'll always be consistent. Take your y value, take half of it and minus 2. These ones are going to be the same because they started the same. A half minus 2. Decimals or mixed numbers, whatever you want to do. Negative a half minus 2. These are my points. So I am going to set up some axes. All my x's are positive, so I don't need any space to the left. And all my y's are negative, so I don't need any space up above. My x's are counting by pi, so don't go like 1 tick mark and call that pi. Leave a little bit of space, right? So let's call this pi. 1, 2, 3, 4, 5, 6 pi. And my y's have halves in there, so I'm just going to go here, negative 1, negative 2, negative 3, so that things aren't so smushed. And I'm going to plot the points that we found. Pause the video and plot the points. Try to make it look like a sine curve, like a wave. This is 1 period of sine. It does go on forever, but we're not going to graph it forever. We're going to graph 1 period of sine. And then I'm going to write some answer blanks. Okay, pause the video and copy down those answer blanks that I just wrote down. See which ones you can answer if you'd like. So domain, remember we graph one period, but it goes on forever to the left and the right. That means domain is all real numbers. Range, the lowest my graph goes. Range is bottom to the top, and range is brackets if it touches it. The lowest my graph goes is negative 2.5 or negative 2.5. And the highest my graph goes is negative 1.5 or negative 1.5. Brackets because it's a range and it's touching those points. Relative minimum, I believe I made that blue last night. The bottom of a valley is at 5 pi. But this is just one cycle. That continues on and on forever, and it continues every 4 pi. So plus or minus 4 pi n. The period for this is 4 pi. And that point is at negative 2.5. These are parentheses because it's a point. Do the relative max. Top of a hill. That is at 3 pi. But it happens every plus minus 4 pi n. And it is at negative 1.5. Parentheses because it's a point. Even odd neither. You can try to back your graph up. If you've spaced it out nicely, you can try to figure out what's going to happen if you go backwards. But in case it's not a nice number, we should be able to find it algebraically. So over here, because I ran out of space, I'm going to plug 0 into the original equation. So 1/2 sine, half of 0 just goes away, minus pi minus 2. So here we go again, unit circle. Negative pi takes me here. Sine is the y value. What is sine at negative pi? The y value there is 0. So I get negative 2. So 0 comma negative 2 for the final answer. And since 0 comma negative 2 is not a min or a max, this one is neither. Pause the video if you need to. Okay, number 2 is already in graphing form because there's an imaginary 1 squeezed right here. That's our b value. See if you can answer those answer blanks. Pause the video because I'm going to pause mine and fill them in, and I'm just going to unpause and you're going to see all my answers right away. Did you remember that amplitude is always positive? Did you remember to make that a positive 2? And then the fact that it's negative is why, yes, there is a vertical reflection. Okay, this time it's cosine. We need to make a cosine table. As you go around the unit circle, starting at 0 radians, cosine is the x value. What's x at that dot? X is positive 1 because the radius is 1. Then you go up to pi over 2. What's cosine? What's the x value there? It's 0. Then you're going around to pi. The x value there is negative 1. Then you're down at 3 pi over 2. The x value there is 0. And then you're back at 2 pi. And the x value there is 1 again. These are your original points. See if you can come up with the formula for what you're going to do. Okay, let's do the x's together. So 0 plus pi over 3 is clearly pi over 3. I'm actually going to add an answer column here because I'm going to do some stuff as we go. Okay, pi over 2 plus 3 pi over 2. So common denominator is going to be 6. So times 3 is going to be 3 pi over 6 plus, and on that one, times 2 is going to be 2 pi over 6. That's just common denominator. That's how we add fractions. Add those together and you get 5 pi over 6. Now that I know that one is going to be over 6ths, the answer to the one above it is pi over 3. That's perfectly acceptable. But it's going to be easier if you make it also have a common denominator. So I'm going to times that one by 2, and this is 2 pi over 6. Okay, let's do the next one. Pi plus pi over 3. So 3 pi over 3 plus pi over 3 is going to be 4 pi over 3. But I want it to match and be a common denominator. So times 2 times 2, I'm going to write 8 pi over 6 here. And here's why. Plus 3 plus 3. Now I can see the pattern. 8 plus 3, 11 plus 3. And now I finish the rest of them without having to do all the math. Pause it and find your y values. Negative 2 times y plus 1. check your table with mine. So all the x's are positive, so I don't need any negative x, but my y's go down the -1 and up to 3, so I'm going to need a little bit of space on my y's. Okay, my x's are over 6's, so I'm going to count by 6. I need to go all the way to 14, so this has got to be 1 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pi over 6. And I have enough space on my y-axis. Not really. So 1, 2, 3, and -1, -2. Okay, plot the points that we got. This is what you get when you plot the points. Clearly it looks like an absolute value or a v, but it is supposed to be a cosine curve. Try to make it look like it's going down a mountain into a valley on that side, and down a mountain into a valley on that side. Pause it and copy down the answer blanks. Fill out as many of them as you can. Domain, again, this is one period, one cycle of cosine, but it goes on forever, all real numbers. The lowest my graph goes is -1, and it touches that. Smallest number first. The highest my graph goes is 3, and it touches that. Relative minimum, there are 2 in this graph, but you will notice I always choose the left one when I'm writing them down. You can choose the right one, and it would still be correct. So that is that. And it's also fine to leave this not reduced in your answer, 2 pi over 6, but it happens every period, so plus minus 2 pi n. And that value is at -1, parentheses because it's a point. Do relative max if you haven't yet. It is happening at, again, 8 pi over 6 is acceptable every period, and it is at 3 as a point. Y-intercept, you can try to back your graph up, or we need to be able to do it algebraically when it gets harder. Plugging 0 into the original function, x just goes away, and I'm left with the -pi over 3. This one. So on your unit circle, -pi over 3, the over 3's are the ones that are really close to the x-axis, but negative puts it in quadrant 4. Cosine is the x value. What's the x value right there? That's positive a half because it's to the right and it's the small number. Half of -2 is -1 plus 1 is 0, 0. That was not a min or a max, so that was the answer to y-intercept. That is not my min or max, and there's a vertical shift, so this is neither. Okay, last one, and you're going to have to do a couple of these in your bookwork, so take a second and copy it down. It, again, doesn't match my graph paper perfectly, but I tried to put all those dots in a nice spot. We're going to find at least 2 possible equations. So pause it and copy it down, and then I'm going to show you where I'm going to choose to do my equations from. So my equation, when I look at this, I see a sine curve. There's an infinite number of answers for this, right? That's why we only graph one period of sine and one period of cosine. Because when you look at this, you have no clue if it was supposed to be sine or cosine, because it depends. So when I look at this, I see a sine curve here. I'm highlighting it in light blue. Hopefully you can see that. So I'm going to do one answer for if it starts here, if it ends here, and it's a sine curve. I also see, hopefully this looks different, a cosine curve. I see a cosine curve here. So I'm going to write a separate equation, because it could be the answer, for that cosine. What if cosine started there and ended there? Okay, for both of these, you can see the midline. Whether it's sine or cosine, I can see the middle. The middle is at +2. So that means your graph was shifted up 2. So both of these are going to have a +2 at the end. Hopefully you can see that +2 over there. I'm going to write that one below. +2. Okay. So that takes care of D. Then I can also see the amplitude. Whether this is sine or cosine, this height, which coincidentally is a 2, is the amplitude for both of these. So both of these are going to start with a 2. And both my blue and my purple, it's going uphill. So it is positive for both of these. Let's also fill out the trig function. So the blue one was going to be sine. I need some space for everything else. And the purple one, I started writing it on both sides. Let me just get rid of this. The purple one is going to be also y equals. Y equals to cosine, and I need some space for this stuff. Let's see if I can lightly make it purple. There you go. Okay, now we have to look at one at a time. So let's look at sine, the blue one. The original starting point for sine is usually on the y-axis. So this has moved left pi over 4. What do you do to your equation to move it left pi over 4? X plus pi over 4. Now let's look at cosine. The original starting point for cosine is usually on the y-axis. That's the cycle we choose to graph, and it starts on the y-axis. So that one has moved left pi over 2. So x plus pi over 2 to make them start in the right spot. Last thing is period. For both of these, because it's the same graph, right? It's one graph, so they're going to have the same period. If we look at cosine, the purple one, the period is from negative pi over 2 to positive pi over 2. What's that distance? From negative a half to positive a half. So if it's half a unit to the right, left, and half to the right, it's got a total of pi for the period. That is not the number that goes in your equation, right? What's the formula for period? For sine and cosine, the formula for period is 2 pi divided by b, and we just found out it's supposed to equal pi. So what does b have to be? That's a lot of b's. In order for 2 pi divided by it to equal pi, well, b must equal 2. So if I squeeze a 2 in both of these, this is two different equations for the same curve. Okay, so you guys have bookwork. I asked the sub to have the solution manual available for you. I expect you to use your time wisely, and I hope you guys are doing well.